how do we find the average value of a function? Okay. I'll explain this in more detail later. But this expression here gives me a what? What does this expression give me? A net area. Gives me the area underneath the curve. If I want to know what the average height of a function is, I take the area underneath the curve and divide by the length. Oops, I don't know why I wrote that. Sorry, that's nonsense. I'm getting tired. I should have written b minus a, the length. Sorry, that was nonsense.
It did help us conceptually see, though.
All right, so first of all, why would you want to compute the average value of a function? Let's say your function tells you the temperature at any point in time during the day. Well, then a natural question you might want to ask is, okay, what was the average temperature for the day? Okay? So there are lots of instances where you might want an average value. Okay? So again, if I took something like this function here, sometimes it's up, sometimes it's down. What's its average value? Well, maybe you would guess that its average value is something like this. What are you really doing? You are constructing a rectangle that has the same area as the area underneath the curve. And then if you want to know the height of that rectangle, what do? You take the area of the rectangle and you divide it by its length, and that'll give you its height. Okay? So we find the area underneath the curve, and then divide by its length, and you get the average height. It's a clever little trick. Yeah. We're having fun. Okay? This one's not an exciting answer, but I want to do it so you have a problem in your notes. Okay? Here's the sine curve between 0 and 2 pi. What's the average height of this function between 0 and 2 pi? 0. It's not a very exciting answer, but we'll at least do the work. Okay? So we would say that the average value of the function is 1 over 2 pi minus 0 times the area, which would be 0 to 2 pi of sine of x dx, which gives us 1 over 2 pi times the cosine of x evaluated from 0 to 2 pi. But that gives us 1 over 2 pi times cosine of 2 pi is 1 minus the cosine of 0, which is also 1, which is why we end up with 0. Not a very interesting result, but at least you've got an example of this expression. Oh, yeah. Sorry. Minus, minus, plus. Yep, good catch. The antiderivative of the sine is the minus cosine. Good. So for a much more interesting one, you should try this. Okay? And look at the graph, too. It's a much more interesting problem.